In this tutorial, we are going to use the RTC module to initialize the real-time clock in ARRAY microcontrollers. The RTC module primarily acts as a clock that can provide the program with the time and also supports alarm and notifications functionality. Alright, so let's start a new project and name it MyRTC. As the hardware, we choose the EK-RA6M4 board and then select the usual bare metal minimal settings. For this project, we will now add the necessary stack. The RTC stack can be found under the timers category. We can keep the name as RTC0. We have two options for the clock source. The low-cost oscillator clock is a low-power module and is less accurate. On the other hand, the sub-clock provides higher accuracy but also requires an external oscillator and consumes more power. For this tutorial, we can use the low-cost oscillator as the source. For the rest of the settings, we can keep them at their default values. We can then generate the project contents. Now that the configuration has been generated, we can start working on the source code. To print the time values on the terminal, we will make use of the Sager library. The files can be downloaded from the Sager RTT terminal website and needs to be copied to our source folder. We will add two more files here and we will include them in our source code. In the common utils file, we have got all the macro related to using the Sager library, and in the RTC file, we have the macro definitions related to the real-time clock. In this demo, we will initialize the RTC module, set the date and time, print the calendar values in 3-second intervals, and then we shall transition to the next day as the clock runs out its 24 hours. The first thing we are going to do is declare the function to initialize the RTC, and then we are going to define the function. The function will open the RTC module, set the RTC clock sources, request data from the user to set the calendar, and start the clock. As usual, we will find the API to open the RTC module from the Developer's Assistance menu. And same for setting the clock sources. We will now declare the variables to hold the data for the RTC module. The FSP uses the time.h library and the TM structure to hold the values for the clock. The TM structure requires the values for the minutes, hours, and so on. We need to take note that the values of the year is defined as the number of years after 1900. So for 2023, we need to store the value of 123. As for the month, the value ranges from 0 to 11. We populate the time structure. Then we go back to our RTC initialization function. We will declare the variable to hold the user input. Then we will copy the code block to request user input for calendar values. Then we will store this user input into the relevant variable within the TM structure. In the same way, we will take input for other values in the calendar. Note that the values for the month and year need some offset to suit the structure definition. We will subtract 1900 from the user input for year and subtract 1 from the month. Next, we accept the input for the timer, that is the hour, minute, and seconds value. These values don't need any compensation. Once the user input has been captured and stored, we will then execute the API for starting the clock. This API requires the values that have been stored in the TM structure named set_time. Once that is done, we can call the RTC function into the hull entry function. We will then implement the API for extracting the time from the real-time clock. We will store these values in the get_time variable. We can then write a while loop to extract and print the calendar and time values in regular intervals. As you can see, once we have extracted the values, we need to offset back the year and month to display the correct figures. We also add a 3-second delay. Then we will add the API for extracting the updated RTC values inside our loop. We can now build and debug our program. To view the output in the terminal, we need to find the address of the Sager block from a .map file that is in the debug folder. We will open the JLink RTT viewer and paste this address, and the viewer will then display the output of our program. We want to enter a date towards the end of a month, so we make it the 30th of September in 2021, and the time is set close to midnight. Once the final input is provided, the clock and calendar is set and the RTC starts. The calendar information is shown every 3 seconds. Once the clock has passed midnight, the calendar will update its date to the first day of the next month and reset its 24-hour clock. So, the RTC module handles the value of a clock and calendar by itself, and hence it can be used to support more advanced functions such as alarms.